Welcome. In this video, we are going to take a look at problem 49 from chapter 31 of College Physics 2E by OpenStax. In this problem, we have cow's milk, and if it's produced near nuclear reactors, it can be tested for as little as 1.00 picocuries of an isotope of iodine with atomic mass 131 per liter, and that is to check for possible reactor leakage. And we need to find the mass of that isotope of iodine that has that activity. All right, so let's start with what we know. Okay, we know the activity R is 1.00 picocuries. We have an isotope of iodine with atomic mass A of 131. Okay. We can see table B. For the half-life, and we can find that T1 half is 8.040 days, and that table B is in College Physics 2E. All right, we know Avogadro's number is 6.022 times 10 to the 23, and we will use nuclei per mole. Okay. From chemistry, a mole of the nuclei is equal to the atomic mass. And so we can say we have a mass of 131 grams per mole. And we are looking for, we'll use a little m, we're looking for the mass that has that specific activity. So how much of it? Okay. All right. There's a relation between activity and the number of nuclei, and that is that R is 0.693 times N divided by the half-life. So N is our number of nuclei. R is our activity. Okay. Let's find the N. And so we have 0.693 N is R times the half-life. So N is R times the half-life divided by the 0.693. All right. And so the R, 1.00 picocuries. Let's swap out the P for A times 10 to the minus 12. Now we have curies. Okay. There are 3.70 times 10 to the 10 becquerels per curie. And then the half-life we found was 8.040 days. And we'll get this down to seconds. So there are 24 hours in a day and 3,600 seconds in an hour. Then we need to divide all of that by 0.693. Okay, this gives the number of nuclei of 37,088. So that's how many nuclei we have. All right, so the number of nuclei is going to be Avogadro's number divided by the mass in grams per mole, and then times the mass. Okay, so let's solve for little m, and then we'll see how these units work. So we're going to have the number of nuclei times the grams per mole divided by the number of nuclei per mole, Avogadro's number. Okay, that looks good. So we have number of nuclei is 37088 times the 131 grams per mole. Okay. Then divided by 6.022 times 10 to the 23 nuclei per mole. And we are left with grams. Okay, this is good. And so the mass is going to be 8.067 times 10 to the minus 18 grams. And so let's use 3 sig figs. 8.07 times 10 to the minus 18 grams. And this is the mass of the isotope of iodine that has the atomic mass of 131. That has an activity of 1.00 picocuries. I hope you found that helpful. Let me know in the comment section if you have any questions. Thank you for watching, and I'll see you in the next one.